So trigonometric functions of any angle. At this point, yeah, you still have to have your 30, 45, 60, 90, 180, 270, 360 memorized, but you can move into anything at this point. And we've actually already looked at a lot of this. What was the x value? Yep, so this is x. Y is sine. So this is y. And then how did we find tangent? Very good. I always think sine over cosine. But when you guys first saw it, you were y over x. And then cosecant, secant, cotangent, all I have to do is just reciprocate the function that goes with it. So cosecant is the flip of sine, so that would be 1 over y. Secant's the flip of cosine, so that would be 1 over x. And cotangent then is x over y, because it's the flip of tangent. It is, too. When we move on to something else, the y over x, or the tangent, does become your slope. So that's exactly what a tangent is. Tangent is slope in many ways. So, okay, we are going to be dealing with angles anywhere on there. And one thing to keep in mind, we don't use this very often, but your radius doesn't have to just be 1 anymore. Radius comes from Pythagorean theorem. So if we're going to say the radius can be anything rather than just 1, we got to keep in mind that, oh yeah, okay, so radius, if this is x, this is y, this would be x squared plus y squared and the square root of it. So your radius now is not a given 1 anymore. We're going to have to just expand a little bit to think about those things. All right, quickly reviewing here, I never used to teach this earlier. This is actually where I'm supposed to start teaching you these things. So if all values are positive there, which ones are positive here? Yep, sine and cosecant. Down here, all students, tangent and cotangent. All students take calculus, cosine and secant. Very good. We've already done that, so I was just flying through those. But now here is what we're looking at. Given the points A at -3, 4, and then B at 3, 1, find all 6 trig values for both angles. We're only going to do one at a time. So let's do A. So this is x. This is y. Let's not worry a whole lot about even drawing the triangle. I always draw the triangle. When in doubt, draw the triangle. I do everything from the triangle. But if I don't want to, and I just want to use the shortcuts that we had, I'd have sine of x, cosine of x, tangent of x, cosecant, secant, cotangent. All right, now sine is y, so sine is going to be 4. Cosine is going to be -3. Tangent is sine over cosine. So this is going to be -4 thirds. And then cosecant, I can switch and I can do that as 1/4. Secant can be -1 third. And cotangent can be -3/4. And that would really take care of almost everything there. All right, so Dana, we just discovered an error. I was not happy with the fact that sine was saying 4, and I was explaining that I always just draw a triangle. And sine is opposite over hypotenuse, so we had that 5 down there. So I'm going to back up to the earlier page here. We're going to go, nope, 2 pages before. Here's what I'm going to say. Let's put every single one of these over r. So this would be r over y. R over x. I don't think on the sine and or on the tangent and the cotangent we need that. But if we put our radius down there on the bottom, no matter what, because it's opposite over hypotenuse or adjacent over hypotenuse, I think we're going to get this to go. So I'm going to come back over here. Oops. So if I use that little rule, now shortcutting here, this would be 5. This would be 5. I don't think I need it on that one. So this would turn into 5/4. This one would turn into -5/3. And I don't think I need it there. But I will do a quick check over here on my triangle to make sure. So cosine adjacent over hypotenuse is 3/5. Tangent is 4/3. Yep. Okay. So I'm okay with everything on there. What do you notice on the triangle that I drew? What have I not put on? And Lily said negative. I never put the negative on. And the reason I don't is because I can always fix that when I'm done. I figure out, okay, that is sitting over here in quadrant 2. If it's in quadrant 2, the only thing that's going to stay positive are sine and secant. So I can still fly through all my answers and get the correct thing. Cosecant, thank you for correcting me. Sine and cosecant would be the only ones positive. So I only worry about sines at the very, very, very end. And I don't really care about anything else. So I like our little addition with the radius on there. And now I don't worry too much about it. So I'm going to pause again if I can get my... This one says that the tangent is -5/4. And your cosine is greater than 0. Find sine and secant. So, okay, here is what I worry about. Actually, sometimes I do this first, sometimes I do it last. But if cosine is greater than 0, which quadrant is it in? 4 or 1? Very good. So cosine being positive is either 1 or 4, but then tangent is negative, which means it can't be 1. So we know we're going to be dealing down here in the 4th quadrant. So no matter what I choose to do, the only thing that's going to be positive will be my cosine and my secant. Everything else will be the other way around. So what I would do is draw my triangle. I know that tangent is y over x, so this is 5, this is 4, and then this is going to become square root of 16 plus 25, which is that 41? That was so square root of 41 here. So square root of 41. And so now they want me to find sine, so I would do sine of theta is opposite over hypotenuse, so 5 over the square root of 41. And then secant is the flip of cosine, so I would do cosine first. So cosine is 4 over the square root of 41, which means that secant is, I wrote 11, 41, is square root of 41 over 4. And then this one I'll finish rationalizing. That will be 5 square root of 41 over 41. And then because it's in the 4th quadrant, sine is negative. Secant stays positive. So I never, again, do my signs until the very, very end. And then I would go with that. And you don't have to make the triangle, but you can. And I always find that it's much easier if I make the triangle. Questions for me at all on that? All right. So tangent on this one is undefined, and it's somewhere between pi and 2 pi. Figure out what angle we're talking about. What was it? Yeah, it's going to be in quadrant 3 or 4. And now I'm not very good at I know it's going to be somewhere down there in that region. I'm not good at remembering my tangents. So I can't tell you off the top of my head where tangent goes undefined. But what does tangent equal? Very good. And you went straight from what I was thinking, because tangent is sine over cosine. And so any place cosine hits 0, that is where tangent goes undefined. And now I can tell you where cosine hits 0. Do you recall? Very good, right here. This is the place where it's going to be. So if they asked for it in degrees, it's 270. If they asked for it in radians, 3 pi over 2. And we got that. Very good. Questions for me on that? Starting to use your brain on things. Oh, at the quadrant angles. This one I'm going to let you be on. All I need to remember here is if this is the point, I'm going to go back to the unit circle, because no matter what, we're going to reduce down to the unit circle. So if this is 1 and this is 0, what is cosine at this point? And sine is, so this is cosine at 1, sine at 0. You can get all the rest of them from that. This one is the point 0, 1, which means cosine is 0, sine is 1. This one is the point -1, 0. So cosine's -1, sine is 0. And here, 0, -1. At that point, my cosine is 0, my sine is -1. This is where tangent would be undefined. Yep. And there's where tangent is undefined. What else is undefined here? If cosine is 0, what else would be undefined? The flip. Yep, secant. So tangent and secant are undefined there. So tangent and secant are undefined here. Here, cotangent's undefined. And what else? Cosecant. Very good on the other ones. But you might have to just think your way through them. Timmy, you still here? Okay, just making sure. I have 4 minutes. Do you want me to pause? Reference angle for the following degree measurement. So this one is currently sitting, what quadrant is this one in? 4. So 300 degrees, it's going to be right here. So my reference angle is there. 60, very good, because the full way around would be 360. So I do 360 minus 300, and I get 60 degrees. So we would use a reference angle of 60 degrees. Now, 2.3 is in radians. I don't have those memorized quite as well. So I know that this is 3.14. This was 1.57, something like that. So 2.3 is going to be, I should have drawn it over here. 2.3 would be sitting here, somewhere in there. So in order to figure out the reference angle, I want to finish going all of the way to pi. Very good. And all I would do is take pi minus 2.3 because I just want to finish out the journey to pi. So pi minus 2.3, 0.84. I'll take it. Very good. So then if I'm sitting with a -135, -1, and there was one of these on your quiz too. What quadrant is it in? Very good. -135 is in here. So in order to finish it out, what measurement am I trying to get it to? 180. So all I would worry about here is 180 minus 135. You can't ever have a negative reference angle. It won't impact anything. So you just go with that and you would end up with 45 degrees and you're good to go. 2 pi over 3. What quadrant is that one in? Oh, true. Faster way to get it. Connor just said 60 degrees. 2 pi over 3. If they're written in that format, that's very true. That is your reference angle right there. We can use that, especially if it's a 30 or a 60 or a 45. All right, now they will come with those. We're going to be using this, which I think is weird because your book made you do this all the way in section 1, and then they didn't even teach reference angles until now, which is why I taught you reference angles earlier. So if we're looking at 4 pi over 3, what is my reference angle? 60. So what is sine at 60? Oh, well, you guys maybe need to review that. Square root of 3 over 2. Now is when we stop and we think, okay, what quadrant was 4 pi over 3 in? So it's 4 60-degree angles, right? So 3 is correct. Yep, this is in quadrant 3. So all students take calculus. Sine should be negative there, and I make it negative.